Have you ever wondered what happens inside a black hole or how the universe began? In this video, we're going to explore and learn about one of the greatest scientists of our time, Stephen Hawking. Even though a disease took away his ability to move and speak, his brilliant mind helped us understand some of the most mysterious objects in the universe, black holes. Let's discover how one person's curiosity and determination changed science forever. Stephen William Hawking was born on January 8th, 1942, in Oxford, England. Here's something really interesting. He was born exactly 300 years after the famous scientist Galileo died. It's like the universe was passing the torch of scientific discovery. That's crazy. As a kid, Stephen loved asking big questions about how things worked. He wasn't always the best student. He actually got bored with school sometimes because it seemed too easy. He was a naturally curious person, and he often wondered about the universe. At age 17, he went to the University College in Oxford to study physics. He wanted to study math, but Oxford didn't really offer that as a major, so physics became his path. When Stephen was just 21 years old, about the age of a college junior or senior, he received devastating news. Doctors diagnosed him with ALS, which is sometimes called Lou Gehrig's disease. This disease gradually takes away a person's ability to control their muscles. Doctors told him he might only have 2 years to live. But Stephen didn't give up. He said, "My expectations were reduced to zero when I was 21. Everything since then has been a bonus." Over time, ALS paralyzed his body. By 1985, he couldn't speak anymore and had to use computerized voice systems to communicate. But here's the amazing part. While his body became weaker, his mind became sharper and more brilliant. He lived to be 76 years old, and some of his most important work came after his diagnosis. This teaches us something important. Physical challenges don't define what our minds can achieve. Stephen Hawking proved that determination and curiosity can overcome incredible obstacles. Before we talk about Stephen Hawking's great discoveries, we need to understand what black holes are. Imagine you're trying to throw a ball into the air. On Earth, if you throw it hard enough, or about 7 miles per second, it would escape Earth's gravity and fly into space. Well, that's called escape velocity. Now imagine an object so heavy and dense that even light, which travels at 186,000 miles per second, can't escape gravity. Well, that's a black hole. Black holes form when massive stars, much bigger than our sun, collapse under their own weight, and pretty much it's the end of their lives. The boundary around a black hole is called the event horizon. Once anything crosses this boundary, even light, it can never escape. That's why black holes appear completely black. At the center is something called a singularity, where all black holes' masses are compressed into an infinitely tiny point. In the 1960s, scientists were debating whether the universe had a beginning or had always existed. Stephen Hawking worked with another scientist named Roger Penrose and used powerful mathematics to prove something amazing. The universe must have had a beginning. They showed that if you run the universe backward in time, like watching a video in reverse, everything gets closer and closer together until it reaches a point called a singularity. An infinitely small, infinitely dense point where the universe began. This became known as the Big Bang Theory, which is now scientists' best explanation for how the universe started, and they estimate this happened over 13.8 billion years ago. Hawking and Penrose also proved that singularities exist at the center of black holes. This work earned them major recognition in the scientific community and set the stage for Hawking's later discoveries. In 1971, Hawking made another groundbreaking discovery called the black hole area theorem. He proved that no matter what happens to a black hole, even if it loses energy or collides with other black holes, the total area of its event horizon can never get smaller. It can only stay the same or get bigger. Think of it like this. Imagine you had a balloon, and once it inflates, it can never shrink, only stay the same size or get even bigger. That's similar to what happens with black holes. This discovery was important because it connected black holes to something called thermodynamics, which is the study of heat and energy. Scientists realized that black holes weren't just simple objects. They had properties similar to temperature and entropy, which is a measure of disorder within a system. This opened up a whole new way of thinking about black holes. Now we get to the discovery that changed everything. It's Hawking's most famous discovery, the one that shocked the entire scientific world. Remember how we said nothing can escape a black hole? Well, Hawking discovered that wasn't entirely true. In 1974, Hawking combined quantum mechanics, or the physics of tiny particles, with Einstein's theory of gravity. He discovered that black holes actually emit radiation. Here's how it works. According to quantum physics, empty space isn't really empty. Tiny particle pairs constantly pop into existence and disappear. Near a black hole's event horizon, something special can happen. One particle might fall into the black hole while its partner escapes into space. The escaping particle looks like radiation coming from the black hole. This radiation is now called Hawking radiation. It means black holes aren't completely black. They glow very, very faintly. Over incredibly long periods of time, we're talking about trillions and trillions of years, a black hole could actually evaporate completely by losing mass through the radiation. When Hawking discovered this, many scientists were shocked, and it changed how we think about black holes forever. His discovery of Hawking radiation created a new puzzle called the information paradox. In quantum mechanics, information about particles can never truly be destroyed. It's the fundamental rule of physics. Remember, matter cannot be created or destroyed. But if a black hole swallows something and even evaporates it through Hawking radiation, where does the information about what fell in go? Does it disappear? Would it break the rules of quantum mechanics? Or is it somehow preserved? Scientists are still working on solving this puzzle today. This paradox has inspired decades of research and continues to be one of the biggest mysteries in physics. Hawking himself worked on potential solutions for the rest of his life. Stephen Hawking made many other contributions within science. He developed the, quote, no boundary proposal, end quote, which suggests that time didn't exist before the Big Bang because there was no space-time before the universe began. Think about it. If time itself was created with the universe, asking what came before it is like asking what's north of the North Pole. Hawking also became famous for making science accessible to everyone. In 1988, he published A Brief History of Time, a book that explained complex ideas about the universe in ways regular people could understand it. It became one of the best-selling science books ever written, staying on the bestseller list for over 237 weeks. He appeared on TV shows, gave public lectures, and inspired millions of people to be curious about the universe. So you might be wondering, Was Hawking right? Did he contradict his own ideas? How do we know his theories are true? This is where modern technology comes in. In 2015, scientists detected gravitational waves for the first time using an observatory called LIGO. LIGO. Gravitational waves are ripples in spacetime caused by massive cosmic events like black holes colliding. It's like when you drop a pebble in a pond and you see the ripples spread out, except these ripples travel through space itself. In 2021, scientists used gravitational wave data from merging black holes to test Hawking's area theorem. They measured the black holes before and after they merged and confirmed that the total area of the vent horizons increased, just as Stephen Hawking predicted. In 2025, scientists reported even stronger confirmation with even more precision. When Stephen heard about the first gravitational waves detected in 2015, he immediately called his colleague Kip Thorne to ask if they could use it to test his theorem. Sadly, Hawking died in 2018 before seeing his theorem observationally be confirmed. But his predictions turned out to be correct. Scientists have even created laboratory experiments to test Hawking radiation. Obviously, we can't create real black holes in a lab. That would be dangerous and, quite frankly, impossible. But scientists have gotten creative. In 2022, researchers used chains of about 8,000 supercooled atoms to create conditions that mimic what happens near a black hole's event horizon. They detected a temperature increase in the chain that matched what Stephen Hawking's theory predicted for Hawking radiation. These experiments couldn't prove Hawking radiation exists in real black holes. Those are just too far away and the radiation is way too faint to detect directly. But they showed that the physics behind Hawking's ideas work exactly as he described. Scientists are also using telescopes to search for primordial black holes, tiny black holes that might have even formed shortly after the Big Bang. If these exist and evaporate through Hawking radiation, they might produce detectable gamma ray bursts that telescopes should be able to see. Stephen Hawking's work continues to shape modern physics and astronomy. Scientists around the world use his theories to 1. Understand how the universe began and how it might end, 2. Study black holes using gravitational wave detectors like LIGO, Virgo, and the upcoming Einstein periscope, 3. Work towards the theory of everything that combines quantum mechanics and gravity, and 4. Explore the nature of space, time, and reality itself. New discoveries are being made all the time that build on Hawking's foundation. Every time a gravitational wave is detected, scientists test his predictions. Future space missions and more sensitive detectors might even directly observe Hawking radiation one day. How cool is that? Stephen Hawking died on March 14th, 2018, which happens to be Pi Day and Albert Einstein's birthday. His ashes were placed in Westminster Abbey in London between the graves of Isaac Newton and Charles Darwin. This was to show how important his contributions to science were. He's honored alongside some of history's greatest scientists. But Hawking's real legacy isn't just in his discoveries. It's the inspiration he gave to millions of people. He just showed that, 1, physical limitations don't limit what your mind can achieve. 2, curiosity and determination can overcome incredible obstacles. 3, science can help us understand the most profound mysteries of the universe. And 4, complex ideas can be shared with everyone, not just scientists. Stephen Hawking once said, "Look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist. Be curious." Hawking's story teaches us that asking questions is the first step to discovery. He wondered what happens in black holes, and his curiosity led to revolutionary discoveries. What questions do you have about the universe? Maybe one of you will grow up to answer them. Remember, every scientist starts by being curious. Every discovery begins with someone asking why or how, just like Stephen Hawking did when he was, well, your guys' ages. The universe is full of mysteries waiting to be solved. Maybe you'll be the next person to make groundbreaking discoveries about black holes, the Big Bang, or something we haven't even imagined yet. Stay curious, keep asking questions, and never, ever stop learning.